All right, today we're going to start chapter 3. Chapter 3 starts out talking about maximum and minimum values. And one thing to keep in mind, this is going to be a big topic, finding maximums and minimums throughout all of chapter 3 and throughout the entire year, actually. Whenever we're asked to find values, the value of a function or the absolute maximum, minimum values, keep in mind that these are y values. So these questions will be asked of you in different ways. They might ask you for the maximum value. They might ask you for the x value at which the maximum occurs. So make sure you know what you are being asked for. Anytime you are asked for a maximum value, remember that is referring to a y value. Okay? Now, the absolute maximum. The absolute maximum value is the largest y value that occurs over the domain of the function. So they might say that, we're just talking about the interval from 0 to 5. What is the absolute maximum value of the function? You're looking for the biggest y that occurs on this interval. And keep in mind, when we're talking about absolute, that those absolute maximums or minimums can occur at the endpoints of the interval. They might occur at 0. It might occur at 5. So we're looking for the biggest y value. And absolute minimum value, well, that's the smallest y value that occurs. So this is just some vocabulary terms. Local maximum, sometimes this is also in vocabulary. This is also referred to by James or by AP as relative maximum, relative minimum. And the relative or local maximum, well, that's the largest y value, but it has to occur inside the interval. It cannot happen at the endpoints of the interval. Local minimum, smallest y value, inside of the interval. So there we would be talking about something like from 0 to 5, but we're not going to include 0 and 5. And critical numbers. Critical numbers we're going to talk about a little bit about today. We're going to use throughout the chapter. Critical numbers, these are x values. X values that make the derivative 0. Or sometimes they make the derivative not exist. We're going to see some critical values when we get to slide 4 today. And these do help us identify maximums and minimums of functions over particular intervals. Now, at any time during this or any other recorded lesson, good idea to have your hand near the pause button. You ever got to slow it down, write something down, make some sense of something before you move on, feel free to do that and do that wisely. All right, that's a lot of vocabulary. We have something called the extreme value theorem. And it says if f is a continuous function, we got a closed interval from a to b, so a and b are part of this interval. Then the function has both an absolute max and absolute min somewhere in this interval. So let's take a look at some examples. What if we have something that looks like this? We've got ourselves a horizontal line. Now, I've drawn that at, I think it's about y equals 4. And so, if I'm going from A to B, there's my interval. the absolute max, and we're talking values, so this is the y value. Absolute max value is 4. And the absolute minimum value is also 4. And we did see that this is a continuous function from A to B. Well, what if we're going to go from A to B again? Maybe we'll again put A here and put B here. But this time we got something that looks like this. Well, now that's again a continuous function. And it looks like the absolute max. I'm not going to give the value here. I'd like the x value of the absolute max. And I'm going to say the x value of the absolute max occurs at x equals b. So if I'm asked for the x value of the absolute max, the highest y value we attain is at b. And the absolute min, again, if I'm asked for an x value, then I'm going to say, well, that occurs at x is equal to a. So it all depends on how the question is asked of you. Do they want the value or do they want the x value at which it occurs? Now maybe. We've got A here and we've got B here. We've got something that looks like this. Now, these, the absolute max and the absolute min, occur at places other than the endpoints. See, this place right here, this is the top of a hill. And the top of a hill inside of the interval gives us a local, this is a local max. And the bottom of a hill inside of the interval, this is a local min. But if we look at this interval from A to B, where's the biggest y value that ever occurs? Well, that occurs right here as well. That's not only a local max, that's also an absolute max. And this is not only a local min, that's also the lowest y value to be found anywhere in this interval. And so that also serves as the absolute minimum. So locals are the top or bottom of a hill. As I look at this example, there was no top or bottom of a hill. There is no local or relative max nor min. Here, no local or relative max nor min. But in this third example here, yeah, we see tops and bottoms of hills. Those are inside the interval, and that would be a local max, local min. And, oh, another example. What about something like this? We're going to go from A to B. What if we had something that goes like this? Now, for something like that, we would have to say there is no absolute max. Now you'd say, well, geez, it's happening right around there, just before you get to that open dot, just before x is 0, you got an absolute max. But can you give me an x value at which that occurs? Can you give me a definite number? Can you give me a definite y value? You could tell me what you're getting close to, but if you can't give me the actual value, then there is no absolute max. And the same thing is going to occur down here at the bottom. There is no absolute min. Because you can't tell me the x value exactly, and you can't tell me the y value. You can only tell me what you're getting really, really close to. Now, does that violate this extreme value theorem? Well, it really doesn't, because the extreme value theorem says there has to be a max. There has to be a min, but only if the function is continuous. And what we've drawn in that fourth example is a function that's not continuous. So it doesn't have to have an absolute max and an absolute min. So those are some examples of things you can run into. Now, I want you to grab your calculator. This might be one of those places you press pause. And I want you to graph this function using this window for x's and this window for y's. And after you've done that, well then, start playing this again and we'll talk further. Your graph looks something like this. And we want to find all the local and absolute maxes and mins. Now, let's talk about absolute max. Where is the biggest y value? Biggest y value in this interval, starting at -1 and going over here to 3. And I should have been specific here. Name local and absolute maximum and minimum. Let's add the word values here. I think the highest y value occurs right in here somewhere. It's the highest y value of all these in this entire interval. And so what I'm going to do to find out what that point exactly is I'm going to press second, and then the trace button, which is going to give me the calculate function. And then it's going to ask me, what's your lower bound? What's your upper bound? Well, I think that this occurs between -1. Oh, I'm sorry. No, I think that this occurs between an x value of 0 for the lower bound, enter, and an x value of 1 for the upper bound. Then they ask me to guess. Maybe we'll just put in 0.5 and enter that. And what it gives me is it gives me 0.382-ish for the x value, and it gives me a y value of -2.91-ish. I'll go 3 decimal places, and I think those are rounded correctly to 3 decimal places. So if I'm looking for the absolute maximum value, I think that refers to this y value. And so that would be -2.910. Now, one other thing. That's also the top of a hill inside of the interval. Does that also serve as a local maximum? And yes, it does. So these two guys are the same. That y value serves as both the absolute max, because it's the highest one in the interval, and the local max, because it's the top of the hill. Now, what about absolute min? Now, the absolute minimum value appears to occur right here. I don't think there's a lower y value in this entire interval. What I might do to find that is just to press trace and put in 0.5 as my X value. I'm sorry, Jiminy. Thinking about the next problem. I'll put in -1 as the X value. When I press enter, it's going to tell me what the Y value is. And the Y value at that point, I believe, is -21. So my absolute minimum value is -21. If I'm asked at what X value does that occur, well, then my answer to the question would be -1. Now, what about local min? You got the bottom of a hill anywhere in this interval? And I think you would agree with me that we got the bottom of a hill right about here. And that's going to be a local min. And I'm going to want the Y value at that point. So again, I'm going to do this second and calculate, which is the trace button. But now I'm going to tell it that I would like a min. And it's going to ask me between what and what. Well, I think that that occurs between a lower bound of 2 and an upper bound of 3. And then it asks me to guess, and maybe I'll guess 2.5-ish. And I believe that it's going to tell me that at 2.618, at that X value, I get a Y value of -14.090. Again, you feel free to press pause and do this stuff as I'm doing it. Just don't take my word for it. But that local minimum value, if they ask for at what X value does it occur, well, that's right here. If they ask for the Y value, and now we've named our absolute max, our local max, our absolute min, and our local min. So a calculator can be very helpful for things like this, if you're allowed to use your calculator. All right, so we move on. The closed interval method, if you're not allowed to use your calculator, closed interval method for absolute max or absolute min. Pretty easy to do if you can use your calculator. That calculate button's pretty valuable. But a lot of times, and on the AP exam and on your quizzes or tests, you're not allowed to use your calculator, yet you're asked to find an absolute max or absolute min. Step 1 is to find the critical values. We referred to that on slide 1. Vocabulary word. Where does the derivative equal 0? Or possibly, where does the derivative not exist? So we're going to find those critical X values. Step 2 is to find the value of the function. Now we want to find the Y values. The Y values at these critical X values. And then the third and final thing, because this is absolute max, absolute min, the other important points are the beginning and the end of the interval. We've got to find the value of the function. Remember, that means Y value. We got to find the Y value at the end points of the interval. And these endpoints refer to the X values. And the biggest Y value that we find, well, that's the absolute max. And the smallest of all these Y values that we have found, those are the absolute min. All right, well, let's just practice that once before we go on the assignment. And the absolute max, absolute min, for this function right here, here's our interval. These are X values. All right, step 1, find the critical values. What makes the derivative 0? Or not exist? Well, in this case, I think the derivative is going to exist everywhere. I think if I take the derivative correctly, I get 3x squared minus 6x. That occurs everywhere, especially in this interval here, but everywhere. So I'm interested in where this is going to equal 0. Well, what's your strategy for that? And if you're thinking, I'm going to factor this guy, well, good choice. I might factor out a 3x and say, if I multiply that by x minus 2, I'm interested in where this factored version is equal to 0. And it doesn't take much to figure that this is equal to 0 at x is equal to 0. Or x is equal to 2. Those are my critical x values. Now you got to ask yourself, are both of those in this interval? And I think we'd agree that they are. Okay, so now I'm going to move to step 2. Step 1 has been accomplished. Step 2, find the value of the function at these critical values. I'm going back to the original function. I am finding f of 0. I'm putting a 0 into my original function here. And when I do that, I believe that I get 1. I've got to put the other critical value in there. I've got to find f of 2. What's the y value when x is 2? And if I do that correctly, you try it, I think you get -3. Now I'm moving on to step 3. And in step 3, I got to find the y values at the endpoints of the interval. I've got to find f of 0.5. And if I put 0.5 into this equation correctly, and you try it, I think you get 0.375. And I've got to find the y value at the other endpoint of the interval. If I do that correctly, if I put a 4 in here correctly for all these x's, I think I get 17. So now, I've got to find the absolute max and absolute minimum values. So I'm going to say the absolute maximum value is a y value, and it is 17. I'm going to say the absolute minimum value is the smallest y value that I found. I believe that's -3. So hopefully that helps you make sense out of section 3.1. And refer back to these anytime you're working on the assignment and you're asked about finding the absolute max, absolute min, local max, local min for any function.